This video will cover the basic skills you needed to grasp the idea of maps. It can be argued that geography's most important tool for thinking about features of the world is a map or Google Earth. Maps can range in a number of different sizes, shapes, and colors. Some show an insane amount of detail, while others can be as simple as the school map you were given at the beginning of the year. For hundreds of years, geographers have tried to perfect the art of map making, or an official name for it is cartography. For people to understand what a map is trying to show, cartographers must form the maps in a way to ensure that the users know how to use them and they convey the image in a clear, simple fashion. They must make two important decisions when they are creating a map: scale and projection. The two purposes for a map: a tool for storing reference material and for communicating geographic information. As the reference tool, it helps us find the shortest route from point A to point B and to help us avoid getting lost along the way. As a communications tool, a map is useful for showing the distribution of human activities or physical features. Since Earth is a sphere, the best way to represent Earth would be a globe. But a globe is not a very easy thing to photocopy, display on a computer screen, or carry around in the glove box of a car. So in turn, most maps are flat. There are 3D maps, but those are expensive and hard to reproduce. When trying to make a globe, they turn it into a flat map. You're going to get some distortion, and there's not a really good way to stop it. The problem of distortion is really bad for maps that are showing the entire world. 4 types of distortion can result in: the shape of area can be distorted so that it seems more elongated or squat than in reality. The distance between 2 points may be increased or decreased. The relative size of areas may be altered so that one area may appear larger than the other on a map, but in reality is smaller. The direction from one place to the other can be distorted. When making a map, it must be decided upon how much detail is the map going to show. A map of the world will have very few details because there is simply not enough space, whereas a map of your street will have a great amount of detail because of the size of the area being mapped is so small. So the level of detail and amount of area covered by a map is all dependent upon the scale that is given. Map scales come in 3 common ways: the fraction, the ratio, and the written statement. A scale of 1 to 24,000 means that 1 inch, foot, centimeter, meter on the map equals 24,000 of the same unit on the ground. Relative location is how would you tell a stranger to get from one place that they asked. Like if you were asked how to get to the mall, you'd point down Clay's Mill and tell them 4 blocks and turn left. Follow that street for a while and then turn right. Not very specific and has a lot of room to mess up and get lost. But this is the most common type of location. The next is absolute location. That's the location within the grid coordinates. If you were to give someone this location, they would ask you where the mall is. They would most likely not understand you at all. The grid that was spoken of before is the global size grid that consists of made-up lines of latitude and longitude. The latitude lines run across the map from side to side, with the center line being at 0 degrees as the equator. That is the equal distance from the poles, so that explains the name. While longitude lines run from top to south and link, the center line of the group is prime meridian. The line was a bit more difficult to come up with since it had to be decided on where the line was going to be. So in 1884, the International Meridian Conference was held in Washington, D.C. to develop the prime meridian. The Mercator projection. This is not a very common map, but you may still see it from time to time, so it's good that you know what's wrong with it. And all the lane masses are correct in location, but in reality, the sizes of the lane forms are enlarged, so the sizes are crazy. This happened because along the two lines do not meet at the poles, not closing in the land masses, so it's not that good of a map. Goods projection. The land masses are all equal in size and the correct location is reality, so it seems like the perfect map. But if you look closely, you may be able to spot that there are a number of cuts or interruptions that define this map. It pretty much looks like the designer of this map took a globe, cut it in a number of places so the paper would lay flat. The map is difficult to navigate with. The Robinson's projection. This is the common map that you will see. The projection contains distortions within the aspect of size and shape of land masses as well as to distance and direction, but is able to balance all the flaws to produce a wonderful map.